Hello everyone, I am Nikil Logesh J from the Department of Computer Science and Engineering at Sairam Engineering College. In this video, I will explain my end-to-end machine learning project where I used Altair AI Studio to predict both hospital length of stay and 30 days readmission risk, two of the biggest challenges faced by hospitals everywhere. The big challenge in healthcare operation is uncertainty. Hospitals struggle to accurately predict how long each patient will stay after being admitted and which patient at risk of returning within 30 days after discharge. Getting these predictions right is essential for efficient bed planning, staffing, and providing patient care while also reducing unnecessary cost. To tackle this, I began by creating a custom data set. I sourced public hospital datasets from Kaggle and Hugging Face. Here you can see the datasets. Then I used Python script to merge, clean and modify the data as needed for the project. Further features included age, gender, diagnosis, previous admission, vitals like blood pressure, heart rate, and social factors such as insurance and income status. I carefully handles the missing values to ensure every record was usable for training. All of this provided a solid and realistic foundation for predicting model. I focused on two key tasks. First one, predicting the length of stay for every new patient as a regression problem. Estimating the number of days each patient will remain hospitalized. Second, predicting the chance that a patient will readmitted within 30 days, which is a binary classification problem. These predictions empower hospitals to plan resources smarter and intervene earlier at a risk at patient. For both length of stay and readmission, I trained and evaluated three different models using Altair AI Studio. First one, decision forest. Second, generalized linear model. And third, naive Bayes. This multimodal approach ensured robust analytics and allowed for fair performance comparison using key metrics such as RMSE, MAE for length of stay, and accuracy, ROC, AUC, and F1 score for readmission. Let's look into the process image and flow of workflow in Altair AI Studio. Here you could see the length of stay workflow. The workflow starts by loading known values and preparing all incoming patient data. Next, it applies automated missing values, handling and encoding any categorical or text-based feature. Feature engineering process ensure every relevant predictor, demographics, diagnostics, vital, etc. It's formatted exactly as model expected. Through the workflow, I loaded my trained model from Altair AI Studio and automated the prediction for both tasks, producing outputs instantaneously as new data arrives. Importantly, I use explainable AI notes to show which factor influenced each prediction, making results transparent for medical staff. The flow also includes logging steps to store results and explanation, supporting both audits and further analysis. Here you could see the length of stay process, and here you could see the readmission process. When I hit the run button, it starts to evaluate and then boom, the readmission status came. Here you can click visualization and see the length of stay. The value I selected is length of stay. Here you can click which attribute to look, and the selected attribute is length of stay. And then here you can see length of stay. Then I hit run, boom, it starts to evaluate each and every operator. Here you can see the length of stays. When I hit visualization, there is a sunburst method. This is the area and this is the type of the hospitals you are trying. Then you could see the location. For example, SRM Global Hospital is located at Coimbatore, Tirupur, Madurai, Salem, and Chennai. And the sub attribute is you can see whether the patient is having no insurance or insurance provided by the government or is taken by the private. Then you can see whether the patient has taken any medication before admitting. Here you can see the patient taken painkiller, insulin, etc. etc. And the last stage is the analysis for length of stay. In my database, there are 50 plus rows. Uh, sorry, 50,000 plus rows. So the number of patients with multiple length of stays can be calculated and predicted very easily. Let me show the accuracy done by the decision tree. When I hit the performance, you can see the range 1 hit percent of accuracy and range 2 hit nearly 100% of accuracy. Similarly, you can see the accuracy for readmission using decision tree. For range 2 it has 0 because I didn't enter the value for range 2, it's empty, so you couldn't able to bring accuracy for empty. For range 1 it's 81% accuracy for readmission. And also I built a real world deployment hosting website. To make my solution accessible, I hosted a simple web application. Hospital staff can enter patient details using a easy form. With one click, they receive prediction for both length of stay and readmission risk, along with the explanation for each. Let me show my web-based application. Here you could see the RMA files I saved. The RMA file for readmission process and RMA file for length of stay. I already hosted this in my GitHub. Let me show that. This is in this repo I hosted through GitHub pages. When I hit try a prediction, you have to enter the age, let's say 70, and gender, let's say male. The primary diagnosis was diabetes and the admission type was emergency. Let's say the blood pressure is around 90 95 and the heart rate is around 82. Usually there will be a Fahrenheit temperature would be 94. And if they admitted before in this hospital for last year, none. Then I hit generate prediction. Okay, the prediction need to be calculated for a temperature above or equal to 95, let's say 96, then I generate prediction. See, the length of stay for would be 8 days. This could may be extended, and the readmission may be a 50-50 chance. And here you could see what would be the clinical recommendations. Actually, I didn't integrate directly RME to this. To integrate RME directly to this, I need to create an API. So I just replicated the RME file workflows for the pre-processing of data and ending data. So I entered that pre-processing workflow in my JavaScript to run this. Here you could see I have mentioned in above the pre-processing workflow and prediction logic inspired by my models. The JavaScript into the same data transformation age such as and found in my these two. In this in summary, this project demonstrates how to solve an important hospital problem with end-to-end automation, from data preparation and robust modeling in Altair AI Studio to explainable prediction and real-time web deployment. Thank you so much for watching. If you have any questions or feedback or would like to see a demo, please leave a comment below. Thank you.